All right, in assignment number 5, we're going to be introduced to the idea of logarithms and what logarithmic form is. Logarithms are what we use to solve exponential functions, and so it's an important concept, and we're just going to be scratching the surface today. Let's go ahead and get started talking about what logarithmic form looks like. We already know exponential form. That's y equals a times b to the x. But I can put anything that's in exponential form, I can put in logarithmic form. The b here is the same thing as the base over here. Then we have the y, which is the same thing as like what our answer would be in exponential form. And then our answer in logarithmic form, or x, is the actual exponent. And so one of the things that you'll see me do a lot is I will maybe kind of make a circle that looks like this. This is b to the x equals y. And so here we have 3 to the 6th equals 729. We want to write that in logarithmic form. So it's just going to be the log base b, which our base is 3, of 729 equals 6. And so this means the same thing as 3 to the 6th power is 729. We know that 25 is the same thing as 5 squared. So if I were to write this in logarithmic form, we would have the log, the base is 5, of 25 equals 2. And that's how we would say that. The log base 5 of 25 is equal to 2 because 5 squared is 25. So what if we have something like number 3? This is in logarithmic form and we want to write it in exponential form. Well, we can say that 2 to the 3rd power is 1/8, or 1/2 to the 3rd power is 1/8. And I would write it like this. I have 1/2. I'm going to raise that to the 3rd power, and that equals 1/8. So that's how we convert between forms. We're going to do more practice like that on our homework, but let's see if we can evaluate some of these logarithms. What is the log base 4 of 64? Well, you could put an x here. That's what we're looking for. We could rewrite this in exponential form if we wrote it as 4 to the x power equals 64. So you might know that off the top of your head, but another thing that you could do if you don't know what it is you could see if you can rewrite 64 with an exponent. This is the same thing as 4 to the x equals 64 is the same thing as 8 squared. It's the same thing as 4 times 4 times 4, which is 4 to the 3rd power. So if the bases are both 4, that means that the exponents also have to be equal, which means in this case, x is 3. And so what is the log base 4 of 64? Well, it is 3. Let's take a look at another one. Here we have the log base 8 of 16. We can say that this is the same thing as 8 to the x power equals 16. Well, we know that 8 is the same thing as 2 to the 3rd. So this is 2 to the 3rd to the x. This also is the same thing, and 16 is the same thing as 2 to the 4th. Well, 2 to the 3rd to the x is the same thing as 2 to the 3x. And 2 to the 4th is going to remain 2 to the 4th. So what that means is that the bases are the same. That means that 3x has to be equal to 4, which means if I divide both sides by 3, x is 4/3. And so what is the log base 8 of 16? The log base 8 of 16 is 4/3. Let's try another one. Here we have the log base 9 of 27. If I put an x here, I can write this as 9 to the x power equals 27. So I want to get the bases to be the same. I know that 9 is the same thing as 3 squared to the x. 27 is the same thing as 3 to the 3rd. 3 squared to the x is the same thing as 3 to the 2x power, and that equals 3 to the 3rd. So that means that 2x has to be equal to 3, and x is 3/2. halves. So log base 9 of 27 is 3 halves. Let's take a look at one more of these together. Again, I'm going to put an x here, and that's what I'm looking for. I'm looking for what this is equal to, which is x. And I'm going to write this as 64 to the x equals 1 over 32. 64 to the x equals 1 over 32. So I'm going to change both of these. 64, I know, is the same thing as 2 to the 6th power to the x. 32 is the same thing as 2 to the 5th power. So if it's 2 to the 5th power, I can move it to the top. It'll just be 2 to the negative 5th power. So the left side is going to look like this. 2 to the 6x, because when I take a power to a power, I multiply them. The right side is 2 to the negative 5th power. Well, that means that 6x must be equal to negative 5. And if I divide by 6, x is negative 5 over 6. So what is the log base 64 of 1/32? That's negative 5 over 6. So this is called a common log. A common log is the only log that you can do on your calculator, at least at this point, and it doesn't have a base listed. If it doesn't have a base listed, then the base is just 10. We're going to use a base 10 more than any other base, and that's why it's called a common logarithm. And so if I want to find out what the log of 100 is, well, I can insert a 10 down here for my base. That means I'm going to have 10 to some power equals 100. And you can probably tell by looking at this that x is going to be 2. So the log of 100 is just 2. So the next thing here, the next thing that we're going to talk about is just Richter scales. Richter scale is a common logarithm. Not a common logarithm. It doesn't have a base 10. It really has a base of 30. So if there is a earthquake that's measured, let's say 4 on the Richter scale, that's like 30 to the 4th power. If you have another earthquake that measures 5 on the Richter scale, that's like 30 to the 5th power. And so when you have two earthquakes and one measures 4 on the Richter scale, one measures 5 on the Richter scale, it's not like they're really close together. The one that measures 5 is actually going to be 30 times more powerful than the one that measures 4. And so, so what we want to do is, on our homework, they're going to ask you how much more powerful is one earthquake than another. And if the earthquake has a measure of 5 on the Richter scale, you're just going to take 30 to the 5th divided by, if it measures 4 on the Richter scale, you're going to take 30 to the 4th. And that's going to tell you how much more powerful the top one is than the bottom one. And so we can go over more about that tomorrow in class. Just something interesting that relates to logarithms and exponential functions. And so good luck on your homework assignment. We'll talk more about this in class tomorrow, and we will see you then.